Hi guys, welcome to our fourth computer lab session. In this week, we're going to talk about serial correlation and discrete choice model. For serial correlation, we're going to continue using the uncovered interest rate parity as the applications, for which you may still remember. We're going to request the expected change of the spot exchange rate on the interest rate of both currency. And both the script and the data can be found on Canvas, so you can use it as a skeleton script to modify it when working on the assignment for first part of the assignment 4. And from the script, you may notice that there are two new functions that we're going to use, which are the coef test and NIMUS. They are from the LM test package and the sandwich package, so you have to install and load it first before we further proceed. Because this is video recording, I can't run the install package function, so I already installed it previously. I will simply use library function to load it, and if you didn't install that package before, you have to install it before calling the library function. Since default there are certain portion part of the script is you may already be familiar with, like in the last few assignments, so I'm going to go through it very quickly. So by now you know better than me that you need to set the working directory. It's more easy to set working directory to the folder where you locate the file. And then you use the read.csv function to set the string as vector equals to false to load the data into R and create an object called df_4a, and we call stir function on this object. We found that the dates column is in character type, so we use transform function and coerce the dates column using s.dates. And we check stir function again. Now the dates column is in right type, is in the right class, and we're going to create a linear model by calling an LM function. The first argument is going to be a formula, and we're going to request the change of the spot exchange rate on the interest rate of Australia and US. And data is equals to the data frame. So we create this data frame object, and if we call the summary function with it, it's going to give us a textual output of the regression, which are something that we are pretty familiar with. So now we're going to plot the residual over time. So first of all, we're going to subset the data that have complete observations using the complete.cases. By calling the complete.cases with the data frame, we're going to get a logical vector that returns true for all observations that without missing value and false otherwise. You can see that this data frame has some observations with missing value, and yeah, and then we're going to provide this logical vector on the row as the index. As you may remember, everything before inside this square bracket, everything before the comma is for the index for row, and everything after the comma is index for columns, and without providing anything is implicitly for selecting the columns. So we're going to subset this. If we use stir function on this new object, we can see that this data frame is a smaller data frame, but each observation without any missing values. And the second step we're going to do is not exactly plot the residual. We're going to first extract the residual from the LM model object first. We're going to provide the LM object as the only argument for the residual function to extract the residual from the models, and we're going to wrap it up with unnamed so that it will be a numeric factor, and we're going to provide this residual underscore m1 as the y, and for x we're going to provide the dates, the dates column in this data frame. And you can see that like there are many dots, and we're going to connect it with the line by calling the lines function. Until now we have a residual residual plot over time, but it doesn't tell it is not very informative, right? But things would be a bit different if we add a horizontal line on the x-axis, setting it to be y equals to 0. And from now you can see that like now we can say something. By observations, looks like the positive residuals follow in this model tends to follow the positive residual, and the negative residual tends to follow the negative residuals. So indicating there are some possibility of positive serial correlation. Just to finish up this plot, we're going to give a title, and that's it for this video.